Kalasin Province, there is a prominent mountain called Phu Kum Khao, located in Nohn Buri Subdistrict, Sahatsakhan district, with a height of about 300 meters. This is where the Phu Kum Khao Dinosaur Research and Museum, or Sirindhorn Museum, is located, which is considered the first dinosaur museum in Thailand. The Sirindhorn Museum is special as a natural history museum that is not only a place to display dinosaur bones, but also a center of paleontological knowledge, both in terms of academics, conservation, and the transfer of relationships between living things in the past and present. In particular, fossils from Phu Kum Khao are recognized as one of the most complete dinosaur sites in Southeast Asia and were given the name Sirindhorn Museum by Her Royal Highness Princess Mahachakri Sirindhorn. The story of this place began in 1994 with the keen eyes of Phra Yannawisahn Thera, the abbot of Wat Sakkawan, who at the time noticed fragments that appeared different from ordinary rocks. After examination by experts, it was revealed that these were fossilized dinosaur bones that had been hidden beneath the ground for hundreds of millions of years. Systematic excavation began later that same year through a collaboration between researchers from the Department of Mineral Resources and the Thai-French paleontological team. On November 24, 1995, Her Royal Highness Princess Mahachakri Sirindhorn visited the excavation site in person. Her visit marked the beginning of the development of the Phu Kum Khao Dinosaur Museum as a concrete project. A temporary excavation shelter was built to protect the fossils from sunlight and rain, as well as to provide shade for the research team working tirelessly on site. In the following year, a 375 square meter research building was constructed to serve as a center for the study, conservation, and storage of reference specimens, including dinosaur remains and other contemporary life forms discovered at various sites across Thailand. All of this information is now presented to the public through exhibitions within the museum. We start our visit in Zone 1, titled The Universe and the World. Here, the story begins with the birth of the universe, inviting us to reflect on the vastness of time and space. The exhibit delves into the Big Bang theory and charts the formation of stars, planets, and Earth itself. It also introduces the dramatic event believed to have ended the reign of the dinosaurs, a meteorite impact that reshaped the course of life on our planet. In Zone 2, when the first life appeared, we are taken back to a time when Earth was still a volatile and inhospitable place. Slowly, as the planet cooled and water accumulated, the building blocks of life began to form. The exhibit guides us through the emergence of the earliest microscopic organisms around 3.4 billion years ago. Among them were blue-green algae, which played a crucial role in transforming Earth's atmosphere by releasing oxygen, setting the stage for more complex life to evolve. Next, we step into the Paleozoic Era, a period of profound biological expansion that spanned nearly 300 million years. This zone showcases the incredible diversity of life that emerged, from soft-bodied marine creatures and animals with hard shells to the giant fish that swam in coral-rich seas. The displays at the front showcase fossils of various creatures that inhabited the prehistoric world during these periods. We also witness life's migration onto land, with the appearance of insects, amphibians, and reptiles. The Paleozoic Era ends with a mysterious and massive extinction event, which cleared the way for the rise of the dinosaurs in the eras that followed. In the late Paleozoic Era, all the continents gradually merged into a single immense landmass known as Pangaea. The vast size of this supercontinent meant that its central regions, far from the moderating influence of the sea, became dry and arid, conditions ideally suited to reptiles. These reptiles rose to dominance in the ensuing Mesozoic era, from which dinosaurs emerged as the dominant land animals. During this remarkable era, the land that is now Thailand was home to a wide variety of dinosaurs. Fossil evidence reveals the presence of fierce carnivorous theropods related to Tyrannosaurus rex, gigantic sauropods with long necks and enormous size, and even small, parrot-beaked herbivores. Continued paleontological discoveries in Thailand have significantly contributed to the global understanding of dinosaur evolution, especially in linking reptilian and bird-like species. So far, 16 species of dinosaurs have been discovered in Thailand, 5 of which are unique to the country and found nowhere else in the world. Beyond revealing the physical forms of various species, ongoing discoveries offer valuable insights into their behaviors, how they fed, hunted, protected themselves, and raised their young. Dinosaurs are classified based on their physical characteristics, evolutionary relationships, and fossil evidence, using a system that starts from broad groups and gradually narrows down. All dinosaurs belong to the kingdom Animalia, the phylum Chordata, and the class Reptilia. Within the group Dinosauria, they are divided into two main groups based on hip structure: Saurischia, or lizard-hip dinosaurs, and Ornithischia, or bird-hip dinosaurs. Saurischia includes the theropods, which are bipedal carnivorous dinosaurs such as Tyrannosaurus, and the sauropodomorphs, such as Brachiosaurus, which are long-necked, four-legged herbivorous dinosaurs. Ornithischia, on the other hand, consists entirely of herbivorous dinosaurs, such as the horned Triceratops. Within each of these major groups, dinosaurs are further classified into smaller units such as family, genus, and species, based on various features such as skull shape, leg structure, and type of teeth. Today, classification often uses evolutionary lineage methods or cladistics, which focuses on shared genetic traits to build family trees. These methods sometimes challenge traditional ideas. For instance, some studies suggest that theropods and ornithischians may be more closely related than previously thought and should be grouped into a new clade called Ornithocelida. For a creature to be truly considered a dinosaur, it must be a land-dwelling reptile with an upright posture, and thus flying and marine reptiles are not classified as dinosaurs. Dinosaur footprints, scientifically known as ichnites, are trace fossils that reveal prehistoric activities rather than the remains of animals. Dinosaur footprints were formed when these animals walked on wetlands or muddy areas, such as mudflats, riverbanks, or lake shores. The tracks left behind were gradually covered by new layers of sediment. Over time, this sediment hardened into rock, allowing the footprints to be preserved for millions of years. These footprints, especially in trackways, help analyze species, walking style, speed, and herding behavior. At the end of the Mesozoic era, the world witnessed a mass extinction event that wiped out the dinosaurs in a mysterious cataclysm around 65 million years ago. Scientists have proposed a variety of hypotheses to explain the cause, including an asteroid impact, massive volcanic eruptions, shifts in the Earth's magnetic field, and even competition from mammals. Amidst the lingering mystery, paleobiologists from institutions around the world, including those working at Phu Kum Khao, have dedicated themselves to studying and preserving fossils, breathing life into the past and telling the story of a time when dinosaurs ruled the Earth. After the mass extinction that ended the reign of the dinosaurs, life in the oceans entered a remarkable phase of renewal. With dominant marine reptiles like mosasaurs and plesiosaurs gone, ecological niches were left wide open, creating habitats for new marine communities. In the wake of devastation, the sea became a cradle of innovation, shaping the foundation of the modern marine world. After the extinction of the dinosaurs, the remaining large reptiles gave way to mammals, which rapidly diversified during the Cenozoic era, also known as the Age of Mammals. These creatures came to occupy a wide range of environments, from grasslands and dense forests to oceans and even the skies. This is the world we know today, still home to the descendants of elephants, horses, rhinos, whales, bats, and other major groups of mammals, living examples of the vast evolutionary changes that have unfolded over the past 65 million years. In the last zone, we learn about the story of humans. According to prevailing scientific theory, humans are believed to have evolved from primates, tree-dwelling members of the ape family thought to be our ancestors. It is estimated that around 6 to 7 million years ago, early human lineages began to diverge from the great apes, gradually developing into bipedal creatures adapted to life on the ground. What sets humans apart is the remarkable development of the brain and a level of intelligence far beyond that of other animals. This advanced cognition has empowered us to create everything from stone axes to modern computers. Phu Kum Khao is the most complete site of herbivorous dinosaur fossils in Thailand. Excavations have uncovered more than 700 fossilized bones, including nearly an entire dinosaur skeleton. In 2014, it was officially registered as a protected fossil site.